In this video, we are going to learn about Introduction in Exercise 9.2 Theorems on Limits. Before getting to the theorems on limits, let us see how to write the limit function. Limit x tends to a f of x. This is the way we will write the limit function, where limit x tends to a, we call it as a limit value, and the function, given function is a f of x. Okay, now let us move on to the theorems. First theorem statement: when the given f of x, this part is a polynomial. You know what is meant by polynomial. I give you some example. Polynomial: limit x tends to 5 x square plus 9. Okay, this is a polynomial for the function. When the question is like this, then we can substitute. What we can substitute? We can substitute the limit value in the place of x. So x square plus 9 will become 5 square plus 9. 5 square value will be 25 plus 9. Answer will be 34. So in this way, we will evaluate the limit when the given function is a polynomial. This is the first theorem. Second theorem: when the given function is a constant, for example, limit x tends to 5 and the function is a constant and 9 means there is no x value here to substitute 5. So your direct answer will be 9. Okay, so this is your second theorem statement. Now let us see what are all the third theorem's result. So when the question is in the form of constant in a multiply with f of x, okay, where c is any constant you can have, then what we can do is you can bring this constant outside the limit function. So your answer will be c into limit x tends to x naught f of x. Okay, I have written only in the general way, not any example. Second subdivision: when the limit x tends to x naught, two functions f of x and g of x are in either addition or in a subtraction means you can split the limit function. In what way means? See, limit x tends to x naught f of x plus or minus limit x tends to x naught g of x. So like this, you can split two functions in a addition or in a subtraction way. And similarly, you can also split in the product also. Two terms product la irundaduna and the two terms ko neenga limit value separate substitute pannalam. So limit x tends to x naught f of x into limit x tends to x naught into g of x. So in this way you can split. The same way you can proceed for the quotient also. Quotient means in rational form. இப்போ இந்த மாதிரி ஒரு கொஷின் வந்து ரேஷனல் ஃபார்மில் இருக்குது, p by q ஃபார்மில் இருக்குன்னா இந்த லிமிட் ஃபங்க்ஷனை லிமிட் வேல்யூவை யூ கேன் give it to each of them. That is for numerator and denominator. Limit x tends to x naught f of x whole divided by limit x tends to x naught g of x, provided this denominator value limit x tends to x naught g of x should not be 0. This you should remember. Denominator value should not be 0. Then only your answer will exist. Okay. Suppose in the g of x value, denominator value limit apply panna piragu, if it becomes 0 means what we should do is we should rationalize. I think you know what is rationalize. Rationalize means multiplying and divide by the conjugate for the denominator or the numerator. Okay, so we should rationalize the numerator depending on the question. Now let us see the fourth problem. Fourth theorem: limit x tends to x naught f of x whole power n. When the question is having the power means you can write the power as a whole form. For example, limit x tends to 5 x plus 1 whole power 10 means how can you rewrite this? Limit x tends to 5 x plus 1 the whole power 10. Okay, so as you see, இது ஒரு polynomial பார்த்தா what we will do, we will substitute the 5 in place of x. So 5 plus 1 is 6. We will write 6 power 10. So in this way you can solve the problem using this theorem statement. Clear? Now we are going to see most important theorem statement. Limit x tends to a, x power n minus a power n by x minus a. Answer will be power n, that is n into a power n minus 1. You should remember the powers should be same in the numerator. Then only we can apply this theorem for any question. Okay, so these are the 5 theorems on the intro part.